Hello, today we're gonna discuss about Hadoop architecture, and I know it's a bit difficult to go through each and everything right now, but we can have an overview of the Hadoop architecture. So let's say let's say we have a cluster. We'll make a cluster. So this is our one node, and this is another, 2, 3, 4. Okay. Yeah. So we have a nodes, and let's connect it. Then only it will form a cluster. So in a node, we discussed before also. This is our master node. Let me write it here. And these all are our slave nodes. These all are our slave nodes. Now, this is a cluster. This is a cluster. So all are connected with master node. Okay, all are connected with the master node. So when I say it is connected, what do you mean? What do you mean, like how it is connected? What is the way? How in a real time we'll feel okay, these are connected? So it means that you have installed Hadoop in this system. You have installed Hadoop in this nodes, second, third, fourth. So you have installed Hadoop in each and every nodes. The only difference that we did is we configured these 4 as a slave node and this as a master node. So in that way, we can define a cluster in which node would be the master and which node would be the slave. Okay, so for diagrammatically we are connecting this. This is the master node. These all are connected with the master node. Okay, let me make a connection. This, like how these are connected. Again, I am saying in each and every node Hadoop is installed, and we did a configuration to make these 4 as a slave and this as a master node. I think connection is fine. We will discuss something more also. So I mean, let me not make it very crowdy, so that we won't discuss the important concepts. Now let me define a boundary of this cluster. So this is a boundary of, suppose this is your cluster. Okay, this is your cluster, right? So now this is your Hadoop cluster. Okay, now if you want to store anything, that's what we know, right? Big data storage, big data processing. So suppose if you have some terabytes of data and you want to send it to this cluster. Why you want to send this to the cluster? So that this cluster will store your data. Okay, let's say that all these nodes are of 1 TB. Okay, so let me write this as well. 1 TB, comma 1 TB with having 2 GB RAM. Okay, same. So what's the capacity? 4 TB and 8 GB of the cluster. Okay, so now you are trying, this is a Hadoop cluster. Okay, so you are trying to store a data in the Hadoop cluster. So how data is getting stored in this cluster? Okay, how data stored in the Hadoop cluster. How data stored in the Hadoop? We discussed, yeah, it's in the key value pair. But what's the way? Okay, so Hadoop stores data in HDFS. Now, what is this HDFS? HDFS is a Hadoop distributed file system. So Hadoop stores the data in Hadoop distributed file system. Okay, so whatever you will send, we will treat this cluster as a single system. Okay, and it will store the data in the distributed file system. So that distributed file system method we are calling it as an Hadoop distributed file system, which is nothing but an HDFS. Okay, now next thing. So suppose you have a file. Suppose if you have a file, One minute, guys. You have a file called employees.txt, size, let's say 500 MB. Okay, I have a file employees.txt of 500 MB. Okay, so now tell me, like we have discussed this in the last classes also, that how many block it will occupy, how many block of memories it will occupy, since the size is 500 MB. So we know that from Hadoop 2, each block size is 128 MB. Okay, so number of blocks will be 4, right? 4, right? Yeah, 4 only. 4, right? So let's say, okay. So let's say B1 of 128 MB, then B2 of 128 MB, then B2 of 128 MB, then B3 of again 128 MB, okay, then B4 of, now tell me the remaining size. The remaining size will be the size of the block. Okay, 128, 128, 128. Now remaining is remaining would be okay, MB, which is overall making it of 500 MB size. So there will be a 4 block. There will be 4 block which will for which employee txt required 4 block in order to get stored in this Hadoop cluster. So then my next question is all block like B1, B2, B3, B4 all will lie in the same node? No, right? Because distributed way, right? Because Hadoop will treat it as a single system. Okay, single system. So it will store data in a distributed way, right? So B1 might come here, B2 might come here, B3 might come here, B4 might come here. So there is no guarantee like which file will go where, right? So what happened, like when we will send this file, what will happen? Now this is our next scenario that we will gonna understand, like what are the things in Hadoop 2 that will be taken care when we will try to send a file to the cluster. So let me go through some terminology. This is very important. First thing is name node. Okay. Second thing is data node. Third thing, resource manager. Then node manager. Then journal node. Okay. Secondary, I think secondary name node is the same kind. So journal node. That's it, guys. Yeah. Let me write that. I'll discuss it as secondary node. Okay. I think this concept is now obsoleted in the Hadoop 2, so skip it. Okay, so these are the terminology that we're gonna discuss about that: name node, data node, resource manager, node manager, journal node, secondary node. So let's understand what are these points in the Hadoop architecture. What does it mean, and what are the things that will be taken care when we'll try to send a file to the Hadoop cluster. Okay. So this is our file, right? This is all our blocks of file that we're gonna send it here. Okay. So what happened when we will send this file? I'm sending this to the cluster. Okay, take it. When I will try to send it, what happened? The first interaction will happen with the resource manager. The first interaction will happen with the resource manager. So what is this? This is your resource manager. Okay. Don't consider it as a separate node. Okay. So it's all inside a node only, but I'm trying to show you, like, okay, this is the first interaction. That's why I don't want to mention these things, like because too many crowd, because we are going to deal with lot of terminology. So let me delete these terms. Let me delete these terms itself. Okay, so the first interaction that will happen will be with resource. Sorry guys. The first interaction will happen with the resource manager. What is the responsibility of a resource manager? As the name suggests, this resource manager, the resource manager is responsible for distribution of the resources among the nodes. Now my next question, is the resource manager lies in the master node? Yes, it lies in the master node. It lies in a master node. Okay, so when you will send the employees.txt, the first interaction will happen with the resource manager. Now let me give a color to this. So what happened? This resource manager will be responsible for the allocation of these resources to the multiple nodes. Now I have discussed that this node might be of 1 TB, that doesn't matter, but it doesn't mean like entire file like B1, B2, B3, B4 all will be stored inside this just because of its capacity. No, it will be distributed among the nodes. So these resource planning will be done by the resource manager. Okay. See, there are a lot of things, right? That what was there in the Hadoop 1 and now what is there in Hadoop 2. So I made a small document to make the things very clear, guys. Like made one small document, don't remember what it is. So that document I'll be sharing during my live training classes. That will, if you want to explore more, if you want to learn more, okay, this was the concept in Hadoop 1 and this is the concept in Hadoop 2. So what are the benefits of using Hadoop 2 and what are the things? So I'll highlight few points, but if you want to go in detail, then during our live classes also we'll discuss these things, like what are the difference between Hadoop 1 and Hadoop 2. That might be one of your questions in that is gonna ask in an interview, but it's not a very the point like, okay, we need to learn something by heart. No, we just need to understand, okay, this is the Hadoop 2 thing, and I'll definitely highlight like, okay, these are the things that was there in the Hadoop 1. So first let's understand the architecture of Hadoop 2, then we'll discuss that why this architecture formed. Okay, so this is the resource manager responsibility to distribute the file among the various nodes. Okay, to distribute the file among the various nodes. Guys, I just want to open that. I think this is the one. Yeah, this is the one. Yeah. So this is the document that I have formed between the what is the difference and all and these things. So I'll be sharing these documents during our live classes. So if you want to go through these notes and document to understand, like, okay, I'll explain this, but if you want to keep it as a notes, you can keep that. So let's now focus on it. So resource manager is responsible for distributing the resources between these nodes. Okay. Now the next term, resource manager work is done. Okay. So next term, what is the next thing? What is the next thing? Let's we have noted down something. Name node. Okay, I supposed to write this resource manager at first. So can I say responsible for resource allocation globally, responsible for resource allocation globally among the nodes. Resources means nothing but your distributed files, B1, B2, B3, B4. Okay, now come to the name. I'll use very simple term. Okay, I'll use very simple terms so that you can understand, and then when you will go through the notes, it would be very much clear to you guys. So name node. What is name node? Okay, what is name node? So let's say this is your name node. All are in the master. Okay, this is also under the master node, and this is also under the master node. So this is your name. Color should be black. Name node. This is your name node. Okay. Now, what is the responsibility and features, and what is the responsibility of name node? The first thing. So name node, it maintains a register. It maintains a register that which data resides where. Resource manager responsible for allocation. Okay, allocate this, allocate this, allocate this. But allocation is done. Now, if you want to, if suppose you are sending a put request, okay, put this file into it. Now, in the next go, suppose you want to raise a get request. In that, what will happen? The name node will only help in getting the distributed blocks, and then it will send you the combined file to you. So name node maintain a register. Name node, it maintains a register that which data resides where. So it's the responsibility of a name node. Okay. So let's give some other color to it. Okay. So name node is also global, right? Global among the nodes, right? Like resource manager, it give the it gave you that flexibility, like, okay, allocate these resources, allocate this work, and then name node is like, okay, let me maintain a register that, okay, which data resides where. So this is the duty of name node. Okay. Now, the resource manager also globally, name node is also globally. Now, data node. What is data node? So data node is same like name node, but it resides locally in the nodes. Okay, it resides locally in the node. Means what? I'll write data node here. This is your data node. Okay. This is a data node. So it resides locally. So what will happen when name node say, okay, give me all the files of employee.txt where it is? It will. So data node, what will do? Data node will maintain a local register. So this will give this local register to name node. Then this will give, okay, take it from node 2, take it from node 3, take it from node 4, and name node will combine and say, okay, this is my complete piece of data, and it will then give it as an output. Okay, this is your file. Resource manager. Okay, so we'll come to that also. So you can say name node is a parent and data node is a child also, and it's a global and it's a local. Okay, now next thing is your node manager. So it's a local. It's a local. So I can say local or I can say maintain data locally inside the node. Maintain data locally inside the node. So all the data inside with it, see, it's a 1 TB of a hard disk. So which block is stored, and everything about that is maintained locally inside this data node. So data node, so when a time comes, data node will send the that response to the name node. Now we will maintain data locally inside the node. Now what is the use of node manager? Node manager. Sorry, I have already. What is the use of node manager? Now you want to do some operation. You want to perform some kind of operation. So that operation will be executed inside. Suppose in the employee.txt you are performing some operation, any operation, right? That lot of things. Give me the list of all employees who belongs to Bangalore. So in all block B1, B2, B3 or B4, in each and every block that operation will happen to find out, okay, who all are the employee who belongs to Bangalore. So in that situation, what will happen? The job will be assigned to the resource manager, and that job will be distributed among the node. One node, second node, third node, fourth node. So the job will be like, suppose I'll say one more thing. Let me write one more thing, guys. Select star from employee where place equal to Bangalore. Okay. Now you send this job. Now you send this job to resource manager, and resource manager, what resource manager will do? It will distribute this job among the nodes. Okay, this is the job, guys. Now start working on this. It will say to this slave node, it will say to this slave node, it will say to this slave node, and each and every slave node will response back with the result, and the resource manager will give it back to you. Okay. So this is another uses of resource manager. So earlier there was a concept of job tracker and the task tracker. Okay. Resource manager is kind of same, but it is little bit different. Why? Because this resource manager divides that work, the execution work and the execution work and the monitoring work. Okay, so this got divided. So I won't go in the much detail, guys, because it will be very confusing. So just like, okay, what are the other parts of resource management? It would be very confusing. So let me just go through the overview of it. Like, okay, so these are the things right now. We'll dive in details about each and every concepts. But as of now, just understand that when you will request for a job, like, okay, I want this, so this job will be divided among the nodes, and each and every node will work. Okay, now you send this job, resource manager took it. What will happen? It will give it to the slave node. Now who is responsible for execution of this job inside this node? That is your node manager. that is your node manager. Local execution. Okay. Node manager. Okay, now you have these blocks B1, B2, B3, B4. Let's say division is in such a way that B1 block is here. Okay, now B2 block is here. Now B3 block is here. B4 block is here. Are you understanding my point? Employees.txt. When you send this file, resource manager took this and distributed among the nodes. Name node maintains the register. Okay, these are the things here. Data node is maintaining the data inside it, or maintaining a data. When I say maintaining a data, means within the node, maintaining a data. Okay, where it is. Another thing. Now you want the other concept is like you want to perform some job on the HDFS. Now you want to perform some job on the HDFS. When I say HDFS, it means the distributed file system, the storage technique, how the data will be reside, how will be the data resides in the Hadoop cluster. So when you place a job, select a star from employee where place equal to Bangalore. This job will come to the resource manager. Resource manager distributes this job among. So okay, what is this? What this job is? This job is either can be in the form of Java file, can be in a form of script, can be in a form of a script like in a pig script or in a form of Python script. So this job, like you send a jar, suppose you send a jar, resource manager took this jar. What resource manager will do? The resource manager will distribute this jar among the nodes. Okay, this is the job that you need to perform. That jar will come here. Node manager will execute that jar. Node manager will execute that jar. When the node manager will execute that jar, it means the Java file, means that piece of code. Okay, select a star from employee. Then it will start working on B1 block. So within this B1, who all are from Bangalore? Within this B2, who all are from Bangalore? Within this B3, who all are from Bangalore? So it will give you the result. Now what happened? Now my next question. Okay, very good. You send a jar. I kept it. Resource manager distributed it, and this slave nodes return back to this resource manager. Now what happened? Suppose this might be the case. B2 goes down. This node, the second node goes down. Suppose this node goes down. What happened? Then you will say this job will be failed. Why? Because if B2 data won't be there, it means it would give an incomplete result, which means that is not the output that you are expecting. So if any of these nodes goes down, then the result would be incomplete. So you will say it will fail, right? It will fail. So in order to avoid such scenario, there is a concept which was in Hadoop 1 also, and now it is in Hadoop 2 also, replication factor. Replication factor. Ideally, when you are working on a single node system, replication factor is always 1. Single node means I am saying about this is only one node will be there. And what is the meaning of replication? Duplicacy, that it will copy the data. So when I will say replication factor 3, what does it mean? That in this cluster, B1 data will exist 3 times. B2 exists, the copy of B2 exists 3 times. Copy of B3 exists 3 times. Copy of B4 exists 3 times. And the copy will be, the copy would not be like B1, then B1 in the same node. No, it will be among different. So let's understand this. Suppose you have B1 and the replication factor is 3. What will happen? So it might come here, might not a guaranteed thing, right? And suppose it come here, B1. Done. Now I'll say how many copy of B1 are there? 1, 2, 3. Good. Now B2. Let me come here. So it copied here B2. Okay. Now it copy B2. Now tell me how many B2 are available? 3. Our case is done. Now let's take the B3. Okay. B3. So B3 might be here. Okay. B3 might be here. Okay. How many copy of B3 now? 3, right? Now B4. B4 is the last. So let's do the B4 as well. B4. It might come here or it might go here also. Distribution, right? Resource allocation, right? Name node is maintaining a register for the same. Okay. Now I'll say. Now again the same question I'm going to ask. This node, my second node is down. My second node is down. Now, will I be able to get the result? Yes, you can. Why? Because now there is no longer a dependency on a single slave node. Now there is no dependency on a single slave node, right? Let's say this node is down. Then also you have a copy of B2, B1 and B3 in other nodes. Now you will say all nodes are down. So that is a different scenario. That means like nothing is working, then you won't get anything. But for this small cluster, what I am saying, like suppose if this is down, then you can get the data from here, you can get the data from here, you can get the data from here. Okay, so this is the use of replication factor. Now I'll discuss another. So okay, replication factor. I'll come to journal node and the secondary name node as well. So let me. So I think let's remove this concept of secondary name node because it's on a Hadoop one. So it doesn't matter. You might see, people using secondary name node. I mean journal node as a secondary name node, but that's not the correct answer for the same. So what happened with this name node? See, now my next question. If name node is down, then what happened? If name node is down, then you want a result from employee table. Resource manager will try to contact the name node. Why resource manager will contact the name node? It has to contact, right? Because name node is maintaining all the register that which files are where, which block of files are where. So suppose if name node itself is down, then the cluster will go down. I mean, that's a single point of failure. Your job will never be completed if name node will be down. Okay, it was in Hadoop 1. But in order to avoid, it was in Hadoop 1, that if name node goes down, it means your entire cluster will go off. You cannot perform any operation. So in order to make a Hadoop more reliable, okay, the concept of journal node came. Okay, the concept of journal node came. So what journal node will do? Suppose this is your journal node. Journal node. Okay, so the concept of journal node will come. Now this journal node, what journal node will do? Okay, so this name node understand guys, name node maintains a register. So the moment when it will maintain a register, it will write it all the data in a place, the common place, which is your journal node. It will write entire its detail. Okay, and journal node will maintain a passive name node, and this is your active name node. Okay, this is your active name node. This is an active name node. So this is active, right? Now name node is having all the data, all the details, right? Now what happened? It will maintain a copy. It will send to the journal node. Journal node, what it will do? It will maintain another node, like, okay, just be ready. The moment when name node will go off, what happened? It will make this name node as active name node, and this name node is already off, so it is a passive one. So again, so this will avoid your single point of failure, and like work will go smoothly. So you can make a reliable system with the help of journal node, which is introduced in Hadoop 2. Now my next question. So there will be only one name node in a cluster? Yes, there will be always one active name node in a cluster. There will be always one active node within a cluster. And journal node is responsible for, can I say like that, maintaining the node, maintaining the name node. Okay? Okay? Done. So, next question. What happened that suppose next question is like, suppose I have given this this job. I think I have discussed all the point, right? Yeah. So in the interview, I'm again saying, in the interview, these points are very important. They might ask, what is the role of name node? What is the role of resource manager? Okay. What is the role of node manager? Okay. What is the role of data node? Okay. So name node and resource manager lie on the master node, which maintains all the slave nodes. Node manager and data node work locally within a node. Now, what is the concept of journal node? Okay. So, and these concepts are very important. So please, always, when you say you are aware of Hadoop architecture, you should be able to explain these things along with the diagram. Now I will back to my question. So my question is, suppose I send this job to the resource manager. Okay, resource manager will allocate, okay, B1, B2. Okay, let's execute this job in the slave node 1, 2, 3, 4. Okay. Now, B1 execution started here. And with a fixed interval, it will send a heartbeat to the resource manager. This node, second node, like he'll say, okay, I am executing B1. It will send a response to the resource manager. Now this, I am executing B2. It will send a heartbeat. Heartbeat means how your heart beats. In the same way, with a fixed interval, it will also beat. It will send a heartbeat to the resource manager. B3, B4. For each and every slave node will send a heartbeat to the resource manager. The moment when the resource manager will understand, okay, heartbeat is not coming, it will declare that particular node as a fail. Okay, so this node got failed. So let me, like suppose it is executing B1 and suppose this node itself goes down. Why? Because heartbeat is not coming. So it will assign this B1 thing to either slave 2 or to slave 4, right? So this is the heartbeat. It will keep sending heartbeats to the resource manager. Question is, suppose B1 is sending request. B1 is sending heartbeat. The heartbeat is very slow. Like it is sending the heartbeat, but it is like, delaying the work, right? Likewise, B2 finished his job, slave 2 finished B2 job, slave 3 finished B3 job, slave 4 finished B4 job. Only B1 is left. B1 is taking a lot of time, but it is still alive. It is taking a lot of time. So what happened? In that situation, what happened? This is a very important question, guys. Like this scenario is called something, I'll tell you. What happened? So this can be one of the questions that can be asked. Like if suppose V1 is alive and it is sending the heartbeat, but it's the processing is very slow and the rest of the nodes finished its job. So what happened in that scenario? So in such situation, resource manager will allocate that job to other nodes, but it won't stop the execution of this node. Now there will be a race between node 1. Suppose node 1 and node 2. Suppose it assigned the job to node 2. So there will be a race between the node 1 and the node 2. Okay. So now again the race will start. So who will win the race? Suppose node 2 finishes execution. So what happened? In that situation, a resource manager will take the output of node 2 and instead, since this node is up and running well, but instead of that also, despite of that, it won't wait for the output of this node. So such scenario is called a speculative execution, where resource manager won't wait, I guess I can say, won't wait for the result from a single node. Won't wait for the result from a single node, and it will assign the job to other node, even the node is alive. If it's alive also, and it won't wait. Suppose other nodes finish its job, so it will assign this to other nodes and it will get the result from there. So such scenario, like resource manager won't wait for the result from a single node, and it will assign the job to other node who finished their job well in advance. Even the node is alive. Now it will take the output from the node which would finish their job first. That's it. So this is your speculative execution, which is one of the important interview question that people asked. Okay. Yeah. So guys, this is all about the Hadoop architecture overview. When we will go through the actual concept, when we will go through the MapReduce programming, which is whole and soul of everything in the Hadoop. So then in that time we'll able to explore more, like, okay, how the things are going on. We'll see the live example, okay, how the files moving and down. So but for the time being, this overview is very important. So I have discussed this. So we'll explore more in our upcoming classes. Thanks.